Hey, welcome in everyone. Looks like a lot of folks are still trickling in. So I think we're gonna wait maybe just like a minute while folks are still joining up, and then we'll kick the presentation off. Okay, it looks like the number stopped climbing. I'm gonna share my screen. Steven, you let me know if this looks good. Looks good. Awesome. Well, yeah, thanks everyone for tuning in for this webinar. No cert, no problem. We're going to talk about some ClickOnce abuse for trusted code execution. This is a only ever so slightly tweaked version of a talk we've given once or twice up to this point, and we've made some additions regarding like some of our experiences since we initially published the research, as well as references to work that's been published since. So just to kick us off, a quick about us. My name is Nick Powers. I work on the adversary simulation team here at SpecterOps as a service architect. I'm primarily focused on red team and pen test engagements, and some of my personal interests include initial access techniques, like some of the stuff we'll be talking about today, some Windows internals, and also authentication relay attacks, specifically over C2, some targeted relay attacks. And I have my handle down here for the Bloodhound Gang Slack as well as Twitter. And I'll pass it off to Steven.
Yeah, so my name is Steven Flores. Just like Nick, work on the adversary simulation side as a service architect here at SpecterOps. Have similar interests, work on red team's penetration tests, trainings, and things like that. So what we hope to accomplish during this talk, we want to take a relatively common initial access technique known as ClickOnce and extend its value for offensive use cases by abusing trust of third-party applications and certificates. So a little bit of an overview of what we'll discuss today. We're going to give a little bit of a background, ClickOnce, if you've never heard of it before. Hopefully get you spun up on that, how it works whenever it's used, current ClickOnce weaponization pressure points, how we can alleviate those particular pressure points, demonstration of weaponization from the things that we'll discuss, and then automation of identifying any sort of other ClickOnce deployments or assemblies that can be abused, and then detection and response overview at the end. So a little bit of background. Initial access attack surfaces are decreasing. Anyone that has done phishing campaigns recently, we have seen that it's becoming more and more increasingly difficult to conduct those. Macros or Office documents have been, for a long time, very popular avenue of access for performing phishing campaigns. Microsoft recently stated that they were going to start disabling macros that were downloaded from the internet, and then reverse that. I don't know where that currently stands, but anyway, Microsoft has for a long time paid attention to, obviously, that there's a very large surface with Office documents and macros related items. So this just looks for ways that we can go around that with that pressure being put onto it. When landing on a target, we have more and more tooling added to endpoints that make it harder for phishing campaigns to be successful. We have things like SmartScreen, which tie into mark of the web, application control, EDR, and sort of endpoint products are all things that we really have to worry about when landing on a target. Overall, really the barrier of entry is getting a lot higher for initial access that we see. And there are some things that we do have to overcome when some hurdles that we would like to overcome. So some things we want to do when performing these actions, we want to be able to install or execute an application without requiring administrative privileges. We would like to, if possible, use reputable or known good file during our execution. We would like the user interaction to be as minimal as possible. The more clicks a person has to do, the more work it is for us to, or the more likely or less likely it will be for us to be successful. And then we would also like for the ease of re-rolling the implementation to be easy for us to perform. So ClickOnce is a deployment technology that enables you to create self-updating Windows-based applications that can be installed and run with minimal user interaction straight from Microsoft. So what this really is just a application or vehicle that's been used to deploy .NET applications to users that would like to use a particular application. Multiple ways that this can be deployed: network shares, file shares, if it's something that's developed internally for an organization. Legacy media like CD-ROMs had the ability to also deploy ClickOnce applications. The most common use case, which we'll focus on today, is through web downloads or web apps, a way that ClickOnce deployments ClickOnce applications can be deployed. For the entire deployment process, which we'll talk about in a couple slides, there we'll be referencing actually throughout this entire slide or slide deck, are manifests, which really describe how the entire deployment and application is set up and how the deployment happens. But over time, there's been a lot of legitimate applications that have been used when installing .NET applications. Previously, at one point, Chrome did this, Fidelity, and there's been tons of others, and we'll talk about ways later on in this slide deck of how we can identify other ones that exist. So as I mentioned before, deployment manifests are going to be an integral part of ClickOnce. There's multiple manifests that we'll talk about. But the first one we'll talk about is the deployment manifest, which ties to the ClickOnce application. And so if you've ever deployed a ClickOnce application, this would be annotated by that .application file. And so what this is going to do is going to reference another manifest that is used during the actual deployment, but it's just going to kind of be a baseline setup for everything that will be used for the rest of the ClickOnce deployment itself. This also does not have to be just the .application file. We'll talk about what other options we have available to us, but this can come in the form of an appref.ms file, which can be used for other web browsers, which again, we'll talk about in the next slide. In addition to the deployment manifest, we also have the application manifest, which is annotated by the .manifest file. And this will be where the ClickOnce deployment finds out all of the specific versioning and dependencies and files that need to be installed alongside the rest of the ClickOnce application when it's been deployed. This will actually also conduct integrity checks from the deployment manifest to make sure that everything adds up and all the files are as they should be. And every file that needs to be delivered will be part of this. If you've ever looked at .NET assemblies or done any sort of assembly identification or looked around in them, you might be familiar with actual .NET assemblies themselves also have manifests. And so the two of those that we'll also be talking about are application and assembly manifests. So the application manifest also can be referred to as unmanaged or fusion manifest, which just has data internally for the assembly itself. The assembly manifest, a lot of times called a managed manifest, again, has other pieces of information that are going to be useful. And a lot of times during the ClickOnce application deployment, you'll see a lot of the checks between these manifests, make sure that they have values that are checked between them to make sure that they add up correctly. And this happens really at runtime during the deployment process. So an example of what a ClickOnce deployment looks like once it's getting ready to be deployed. Here we have the application manifest, the application file, which is one of the manifests. The exe file, which is going to be the actual application itself, and then the application manifest at the bottom. Again, there's going to be multiple manifests that we talk about through this entire talk. So the way that this is deployed, a user will visit an application, something that will point them to the actual deployment manifest itself, the .application file. If you're using an Edge or Internet Explorer browser, as soon as it's visited, a little pop-up shows up saying if you want to open this file, it's downloaded and opened, and then you have a little prompt that you might be familiar with that says, would you like to run this application? And then that's when the execution starts from that point going forward. As I mentioned before, there is another file type that can be leveraged if a user is not using an Edge or Internet Explorer browser. That would be the appref.ms file, which this references all the information surrounding the actual deployment manifest itself. This is going to be downloaded separately via the browser and pretty much like double-clicked or executed in some way in order for the rest of the ClickOnce application to be deployed. So this will serve content from a specific, from whatever the manifest dictates. All the files that need to be downloaded part of this deployment, the DLLs, dependencies, everything else will all be downloaded over HTTP or HTTPS. And then this is going to be saved to the user's app data local directory in this particular directory we have listed here. And then depending on the deployment type, if it's an installation, there will be an installed programs registry key created as well. And all of this process will be handled by a binary called df.svc.exe, which is part of the .NET framework. But most of the functionality on the back end of what's happening is it's being all processed and handled by the system.deployment DLL, which is also part of the .NET framework. We can see here, so a user visits the HTML or just a web app. They are sent to the deploy manifest, the application file. And then once they say deploy, everything else is downloaded. So we have icons, zip files, and other things that are all downloaded part of this entire process. I mentioned that there is, if a user is not using Edge or Internet Explorer based browser, then we can use something like the app.fms file to have it download and still deploy ClickOnce. This would be useful for something like Firefox or Chrome, but this is kind of an example of what we would see in this type of file. It's very basic, has some of the just ClickOnce information, protocol handler for the actual handling of that deployment. So the deployment manifest, again, this is the application file. We mentioned before that it's going to point to the actual ClickOnce or application manifest. And so there's going to be, based on how the web server is set up, it's going to be stored in a certain particular location that's referenced here. So in the application files, usually some versioning, and then we'll have the actual application manifest specified. And so this is where that reference happens at in the deployment manifest. This is an example of what the application manifest for the ClickOnce deployment looks like. It looks pretty similar to an actual .NET assemblies application manifest, but this will also be one of the checks that happens during the deployment. Again, this is other pieces of that same manifest. Earlier, we talked about there's going to be some dependencies and files that are downloaded part of the actual deployment. So you'll see that we have those referenced here and the versions and everything like that. So this is an example of what a .NET Assemblies embedded manifest looks like, or embedded application manifest looks like. We have some basic information. There are some pieces of information here that we'll talk about later that are very important when deploying ClickOnce for one of our use cases. But this is just an example of what that would look like. Same example, just using a different tool to view that same information. So this is what application manifest. We are looking at some other pieces of information that we also have here as well. This is for the .NET assembly itself. So when we have all 4 of these manifests, there's going to be checks that are happening inside of the system.deployment DLL whenever it's running to download it in ClickOnce deployments. And so this is going to be one of the main pieces of code that when all these manifests are being inspected and looked at, where they tell that they're all parsed and make sure that the values really all line up to each other. And so this is just an example of what that looks like and where that is in actual code itself. So we're going to go through our first demo. So if anyone who's ever done a phishing campaign before, you probably have, I would assume, done a ClickOnce deployment as for a payload. And so this is going to be an example of what it's like just to create a vanilla ClickOnce deployment for just straight out of the box, what you would expect. So we're going to go to our HTML. We have our download page. Going to say open. So this is the part I was talking about where it asks you if you want to run this. So the entire thing will be downloaded. And as soon as it's downloaded and executed, we have this prompt known as SmartScreen. that shows up and asks if we want to actually run this application. And so we have to click through a few things in order for this to actually happen. But we do, if the user does click through both of these things, we do see that application actually execute and runs okay. We see here that it's just not signed by any sort of reputable source or anybody that is, any reputation behind that signature.
Okay, so Steven just gave us an overview of what like he mentioned a vanilla ClickOnce deployment might look like. So we stepped through like all of the different manifests that are relevant to ClickOnce deployment, and then what a standard ClickOnce deployment would look like if it was just compiled and then served on the internet. You download, run it, you see like the SmartScreen prompt, things like that. So when we were initially looking into this a while ago now, while we had kind of started this research, we saw this conversation in Bloodhound Gang Slack, where someone's asking about using ClickOnce with an internal code signing cert, and there was a response here that really captured how we saw ClickOnce in its current weaponized state. And the second comment from the bottom says, if you have a cert, then I would 100% recommend looking into ClickOnce. One of the best initial access tools, but really needs a cert to be effective. And at the given the current weaponization of ClickOnce, prior to what we're going to talk about in the following slides, I think we definitely agreed with this sentiment. Like signing the manifests, signing the assembly that would be ultimately deployed with ClickOnce, it seemed very important to have that signed for a number of reasons, and we'll go through some of them. So some of the pressure points with that like vanilla deployment of ClickOnce, we saw the SmartScreen prompt. So the reason SmartScreen was triggered is because we just compile a new C# or .NET assembly that's deployed through ClickOnce, but because that assembly doesn't have any sort of reputation with Microsoft SmartScreen, then you'll get the SmartScreen prompt, because when the file is downloaded, even through ClickOnce, something called mark of the web, a specific file attribute or alternate data stream referred to as mark of the web will be applied to that assembly. So SmartScreen, it's a reputation-based protection, kind of like I just mentioned. It's been a part of Windows since approximately Windows 8.1. And the reputation for SmartScreen can be based on a number of different things. It can be based on just the hash associated with the compiled assembly. It can be associated with the code signing certificate used to sign that assembly. And it can also be associated with the URL from which the assembly has been downloaded. And just as a note, we'll be talking a little bit about this in the next couple slides. There's several different types of code signing certificates. An EV or extended validation code signing certificate, one of the benefits is that the certificate should give immediate reputation with SmartScreen. But without a code signing certificate, ultimately, just like I mentioned, an untrusted or an assembly that does not have any sort of SmartScreen reputation most likely will be executed. So that means SmartScreen will be triggered, potentially endpoint detection or prevention tools will introspect that execution a little bit more intensely based on the lack of reputation associated, the lack of seeing that particular assembly.
Your mic just cut out, Nick.
Okay, this probably doesn't sound as good, but can you hear me okay?
Yep.
Okay. In things like application control and application whitelisting will also be relevant. So continuing on with some of the pressure points, ClickOnce is likely used less often than Office documents from an offensive perspective, which means the internals are likely less explored. So because at the time there was not that ClickOnce hadn't been a popular initial access technique, it was just probably slightly less popular than all of the techniques available from an offensive perspective to weaponize Office documents. So slightly less documentation on like all of the manifests that we kind of covered in the first several slides, and how the integrity checks work and all the stars that have to align to make ClickOnce more viable from an offensive perspective. So another pressure point is the manifest information needs to be accurate or deployment will not work. So here, maybe in 10 or 15 more slides, we're going to talk about the specific attributes that you need to pay closest attention to make sure that your deployment works successfully. And also kind of already mentioned, but a code signing certificate in its current state is kind of needed for higher success rate. That's because SmartScreen, like we talked about, or alternatively like Authenticode code signing certs with associated reputation can be used. But if you're signing your code, there are several concerns that would be applicable, such as attribution concerns. So whenever the correlation of the code signing certificate that you're using is made to like insert pen test company here, then all of the payloads that you've been deploying for however long will be attributed as well. Just on top of the fact that code signing certificates, especially EV code signing certificates, are expensive. The vetting process can be kind of intense. And at the end of the day, whenever that correlation is made, the cert will most likely be revoked or burned in some way. And it's just a lot to take into consideration while also paying for that certificate. So all of that taken into account, what are some things that we can do from an offensive perspective to alleviate some of these pressure points associated with ClickOnce deployments? So legitimate applications make use of ClickOnce. So why can we not just put our code in the code that exists from like a side loading or hijacking perspective? So our initial and probably most straightforward solution to this problem was to take existing ClickOnce deployments and do some sort of hijacking, traditional DLL hijacking, side loading, like app domain manager injection. We'll talk about a little bit of that stuff here in a minute. But one important piece before we start digging into the internals of how some of this works is when we backdoor these existing ClickOnce deployments, we are maintaining the signature of the host of the main assembly associated with that ClickOnce deployment. And this is important because we talked about SmartScreen and the reputation of the assembly that's ultimately executed. It's important to note that we're not making any modifications to the signed and trusted assembly that runs for this ClickOnce deployment that would be backdooring. We are sideloading it using some sort of DLL sideloading technique, app domain manager injection, something like that. Useful tools while we step through this process that we used a lot would include like DNSpy or ILSpy, Res Hacker, which is Resource Hacker, Mage, as well as SigCheck. So identifying existing ClickOnce deployments. The screenshot on the left, you can see if you just open up Visual Studio and you compile a C#.NET project and you publish it as a ClickOnce application, or a ClickOnce deployment rather, you'll see all these files on the left in the left screenshot here. You'll see like an HTML file, setup.exe, and just a lot of default files associated with a ClickOnce deployment. So we took some of the attributes in these default files, and companies like to just kind of rebrand what's published with like default ClickOnce publications from Visual Studio. So we took some of the fields that were more reliably unmodified and used them as like Google Dorks, or a way to kind of pillage through various search engines and find a lot of published ClickOnce deployments.
So let's say that we've gone through, as Nick was just talking about, he showed a Google Dork that can give us a way to identify published ClickOnce applications. So now we've identified some. What's our process or methodology that we should follow when doing this? So the main thing that we want to do is we want to hijack the execution flow of that ClickOnce application that we discovered. So we'll download the application, make sure that it's signed, has or reputable, test this in a VM of some sort, make sure that it runs without SmartScreen being popped open. There is a project that was created after we did this talk from Oddbar Mo, application downloader, where he pretty much, if you believe, will go and download a bunch of all the application files for you, and you can go and get the information. Once you have that app downloaded, you can decompile the .NET code to understand the execution flow, find out where you can get your code injected into. finding dependencies that is not strongly named. We've gone back and forth before of identifying if this was really a problem. From our understanding is that strongly named assemblies do not make a difference because the signature is actually with the manifest itself rather than the actual executing assembly because of the just-in-time compiling. So from what we've seen, it does not seem like strongly naming it really makes a difference when backdooring .NET assembly dependencies. Once we find a dependency that is referenced in our execution flow at whatever point, we'll go ahead and backdoor that DLL and part of the deployment. So we'll decompile that with something like .peek or danspy or whatever your favorite tool is, and then add our code to it and then recompile it and put that back into deployment. Additionally, we can do DLL search order hijacking here as well if we don't want to modify any of that code. Modify the manifests. Again, with manifests are going to be a very important part of the ClickOnce application, and we'll talk about later on easy ways that we can either modify or regenerate manifests. And then recompile everything, make sure everything looks good, and then deploy that application itself. In addition to actually modifying the DLL, and you say you don't want to do search order hijacking, you can also do a few other options that you have available to you if you can find any of these things applicable to your deployment. If there's Node.js, any sort of usage in there, you could potentially backdoor with a node file or any sort of Electron injection or anything like that. If there's any sort of deserialization, you could find a vulnerability in the actual ClickOnce deployment itself and exploit that vulnerability part of the execution to get around that needing to load an unsigned DLL. So an example walkthrough. So we found a deployment. We'll go ahead and download that. We look through the certificate and see it looks like it's signed. So this is a primary or perfect opportunity for us to backdoor this application. We'll open up the application in danspy. We see that we have a bunch of DLLs here that are referenced that were downloaded part of the deployment. So these are perfect for us. We'll step through the code, look at the entry point, and then go from there and find wherever we want in the code that loads a DLL or one of the dependencies, and then we'll go into that DLL. We get to that DLL, we find a perfect location for us to add whatever code we want to do. So we'll go ahead and add that code. So here we have an example of just adding, this is just popping up a notepad, but this is where you can put whatever you want to put for arbitrary code execution. Any sort of .NET code can go right here. But yeah, so we add this code, rebuild that application.
Okay, can you still hear my audio okay?
Yep.
Okay, perfect. So Steven just walked us through what the side loading process would look like. So basically at this point, what we've accomplished would be comparable to side loading like any other .NET assembly. So we have our hijacked execution flow for a signed ClickOnce deployment, but there's still one or two things that we need to tweak before everything works as intended. So the first thing we need to do is modification of the existing ClickOnce deployment. So when you're looking at the ClickOnce deployment manifest, there's a lot of attributes that are optional. So a couple examples of those are the public key token value or the hash block, the values within those the hash blocks. They can just completely be removed. You can recalculate these values or like the checksums of dependencies that you've included in your ClickOnce deployment using, this is an example of using OpenSSL to calculate what that hash value would be. But you can also just remove them and it won't break your ClickOnce deployment. Also, you can add file blocks if you need to introduce additional dependencies. So one reason why you might want to introduce an additional dependency would be app domain manager injection. You want to add a new DLL to the ClickOnce deployment that you found to sideload. You could do that with the file block. I think we talk about here on the next slide. There are some integrity checks that happen in the it should be the application manifest, where it's essentially a checksum of the entire the entire manifest itself. So one thing to be mindful of is if you're just outright removing or modifying portions of existing manifests, then it will break those checksums. So there's a couple additional checks that you need to be mindful of while you're modifying existing manifests specifically. And lastly, kind of in the same vein, modification of these manifests will break integrity of the manifests. So where I mentioned before, if these manifests have been signed and there's some sort of integrity associated, then that will likely appear in like the publisher identity block. Also the hash blocks, like we mentioned, they can have public key token values where the hash value actually exists. But at the end of the day, we think that modification of these manifests or breaking the integrity of these manifests when we're talking about sideloading an existing ClickOnce deployment is okay, because the difference in the prompt that end users receive, like when you're using this as an initial access attempt, is relatively minimal. So when I say relatively minimal, this is basically what I mean. On the left, you can see when we've either broken the integrity of a ClickOnce deployment's manifest, or it just didn't have any sort of reputable code signing cert associated with it in the first place. You'll see the prompt on the left. On the right, if you have some sort of like authentic code or otherwise trusted code signing certificate, you'll see the prompt on the right. So we think that the difference is not like you don't receive an additional prompt, the publisher is marked as unknown, and there's an X instead of an exclamation point. So at this point, we've talked about sideloading a ClickOnce deployment and alleviation of some of the pressure points that we talked about initially. So here we kind of pose the question, do we really need a code signing certificate to effectively weaponize ClickOnce? The difference in the initial prompt is minimal, like we saw on the last slide, and SmartScreen does not impact this verification. And when I say that, I'm talking about in regards to the manifest or the deployment manifest. An authentic code cert would work here. You don't need EV code signing. So when I mentioned EV code signing giving reputation earlier, I was referring to SmartScreen, but here this prompt is not specifically related to SmartScreen. So you could use something less expensive than a code signing certificate. But again, don't really think that the user facing prompt is that different. EV code signing cert is the only solution that's supposed to give immediate SmartScreen reputation to an assembly. Like we talked about before, EV certs are expensive. The vetting is stricter than authentic code certs. And at the end of the day, you can accomplish the same task side loading something that's signed or already has SmartScreen reputation. So instead of paying a ton of money for something that will likely give you immediate SmartScreen reputation, we could use or abuse the reputation associated with someone else's, or the fact that it's signed with a cert that gives immediate reputation. So the first demo that we went through that Steven showed us was just a like vanilla, just compile a C# project, publish it as a ClickOnce deployment, and we saw what that execution flow looked like. Here in the second demo, we're going to show when you have taken somebody else's ClickOnce deployment that either with the host assembly already has some sort of SmartScreen reputation associated, or it's been signed with an EV code signing cert. We'll see how that process differs a little bit. So we're going to our website serving the payload. Again, referencing the .application file, which is our one of our manifests. We see the prompt, we install. And now we receive at least one less prompt specifically associated with SmartScreen, and we achieve successful code execution in the context of a signed process. So just showing here the code signing cert associated. We have a valid code signing cert. To reiterate, we haven't modified the host assembly in any way, so it doesn't break the signature associated with that assembly. We've basically just done either app domain manager injection or some sort of side load to execute our arbitrary code in the context of this process. So we wanted to give a couple shout outs to folks that have published some good stuff since we did the DEF CON talk or since the blog post. One was for Istvan Toth, gave a really good description and much deeper dive than we do in this presentation of stepping through actually showing a lot of steps associated with the sideloading process and sideloading an existing ClickOnce deployment. So that was a really good read, as well as mgeeky wrote a really cool cleanup script that addresses some of like the artifacts left on disk, as well as some registry keys associated with ClickOnce deployments. And there has also been an addition to the OST, Outflank's OST, that has some really interesting and fun ClickOnce capability as well. So up to this point, I guess the major milestones of what we've talked about has been like what ClickOnce consists of, all the manifests that we need to keep track of, all the integrity checks associated with those manifests. And then we proposed the added benefits of taking somebody else's ClickOnce deployment that already has some reputation associated with it, tweaking it, sideloading the host assembly of that deployment, and then seeing what that looks like. But here in when we were initially digging into this topic and we were searching for other people's ClickOnce deployments, we saw, and if you look for ClickOnce deployments, you have probably seen this as well. ClickOnce is not the most popular mechanism to deliver entire applications with dependencies. So when you go searching or using Google Dorks to find some of these, there's only like a few hundred, a couple thousand that you find. And when we were digging into this, we kind of thought like, that's not super viable long-term to just have a relatively small pool to pick from in terms of options for weaponization. So we, several weeks, maybe a couple months, when we had time to like dig back into it, we were consistently looking for a way to take an arbitrary .NET assembly not associated with an existing ClickOnce deployment and basically sideload that, wrap it up as a ClickOnce deployment, and use that for our initial access or weaponization. And it turns out that this could be done, but there are a couple of prerequisites that needed to be met in terms of what that host.NET assembly looks like. So the requirements that we found are that the default embedded application manifest identity needs to not be default. And here in the next slide or two, we'll show what the default assembly identity looks like. And the second one that's a little bit less of an issue typically is the requested privileges value in the embedded manifest. It either needs to not exist or it needs to be set to as invoker in the .NET manifest. So this is related to UAC settings. And we'll also show what that kind of looks like here in a second in a screenshot. Also, if there's just no embedded application manifest, that means that the .NET assembly will be compatible with a ClickOnce deployment. And once we've identified a .NET assembly that meets these prereqs, we basically just complete, or we follow the same steps that we stepped through a few slides ago of like side loading, modifying the manifest, doing what we have to do to get the ClickOnce deployment to a functional state. So as we were looking into this, there were a couple potential inaccuracies that we found in some of the Microsoft documentation that when we were looking for answers of like, the way this started for us was we found a couple arbitrary .NET assemblies that worked with ClickOnce deployments. And we basically just had a bunch of assumptions of why they worked until we did enough reversing to actually get to the answer, which Steven will show us here in a second. We thought we knew, and then we figured out that wasn't actually it. And it took a long time to dig down to what the actual answer was. And some of the documentation kind of led us astray in that regard. This example here is, it says, if your application contains a manifest with UAC details, you must rebuild it without UAC information. This actually ended up not being the case. And if you decompile the system deployment DLL, you'll see exactly where it ends up not being the case. So if you look at the last if statement here, you'll see if and then there's a string require admin or require administrator or highest available. If either one of those UAC settings are set in the embedded manifest, then you'll see that it throws an exception. So there can be UAC information in the embedded manifest. It just needs to be as invoker, which is actually default. So it's not a huge issue. So I mentioned that we'll see the difference between a default embedded manifest versus a non-standard one that might be compatible with ClickOnce. So you'll see on the top, excuse me, if you look at line 4 in that embedded manifest, you'll see assembly identity version 1.0.0, my application.app. So this is what a default embedded manifest looks like for a .NET application, and this will not be compatible to wrap up as a ClickOnce deployment. And we'll show why here in a second. And below you'll see a non-standard embedded manifest, and this would be compatible with a ClickOnce deployment. You'll notice that like line 4 here on the top picture, that default assembly identity does not appear in the bottom. There is an assembly identity, but it's non-standard. We did some reversing in the system deployment DLL, and Steven actually did a lot of the heavy lifting on this part to find the exact difference that made this not work. So I'm going to let him talk about some of the specifics for a second.
Yeah, so if we look at the top screenshot here, we have the assembly manifest information from the ClickOnce deployment. And so this identity information is all the bare minimum that has to be part of the deployment. So we have the name, we have the version, the language, and the processor architecture. If we look back at that previous screenshot of the default identity, we only have 3 pieces of those, 3 pieces of information there. The one piece that is missing is the processor architecture. And so that does not show up in the default application manifest. So there is no way for that ClickOnce deployment to get past this pretty much check, because that processor architecture is not there when it's built in the default manner. So in that sense, those particular .NET assemblies would not be useful, and that information is required as part of the ClickOnce deployment identity.
Awesome. Yeah, and like Steven was mentioning, you can see here in some of the documentation associated with what's required in a ClickOnce application manifest. You'll notice that the processor architecture is a required field, so it wasn't an option to leave that out, and kind of further explains what we were seeing. So initially, we were talking about sideloading somebody else's ClickOnce deployment, and I'd say generally that seems to be the most popular choice for some of the re-implementations of this technique that we've seen. But I think taking an arbitrary .NET assembly and wrapping it up as a ClickOnce deployment has a ton of positive attributes associated with it. One of which is that you don't have to modify somebody else's manifest. You can just generate new ones, and you can do that with mage.exe. You can generate new manifests for sideloading somebody else's ClickOnce deployment, but you'll have to if you're taking an arbitrary .NET assembly and wrapping it up as a ClickOnce deployment. So what is mage.exe? It stands for Manifest Generation and Editing Tool, and it's a command line tool that supports creation and editing of application and deployment manifests, quoted from MSDN. So it comes as a part of the Windows 10 SDK, and you can create, like the definition describes, both application and deployment manifests, the 2 manifests that we'll need to turn this into a ClickOnce deployment using the commands that we've provided here on the slide. So mage.exe makes that super easy. Basically, you just point it at the directory and it will account for all of the dependencies and calculate those checksums and basically do most of what you need for deploying that, at least creating the deployment and application manifest. Again, several integrity related fields are optional, mentioned that kind of before, but if you're changing the DLL that you're backdooring or sideloading and you don't want to constantly have to recalculate those values, just keep in mind that public key token, the hash block, these are optional fields, so they can just be removed. So we've done 2 demos so far. The first one was a standard ClickOnce deployment, no reputation associated. The second one was a ClickOnce deployment of someone else's that we managed to sideload, recalculate the any checksums or make the necessary modifications to the manifest that we needed. And then this third one is where we found an arbitrary .NET assembly that was signed, had SmartScreen reputation associated for whatever reason, and it met the prerequisites that we went over regarding the embedded manifest. So we'll see how the execution looks in regards to this. So a lot of the initial pieces will be the same as the first 2 demos. We visit the deployment manifest, we download, we achieve our arbitrary code execution. So this is kind of similar to the last POC, but this time we'll notice that now we're in the context of this dfmonitor.exe process, which is a part of the Azure SDK, and it's not deployed as a ClickOnce application or a part of any ClickOnce deployment. It just met those prerequisites. The embedded manifest for this .NET assembly contained the right attributes. It didn't have the default assembly identity. It didn't have UAC settings that were not compatible. So it worked as a ClickOnce deployment. So we can see our arbitrary code is executing in the context of this process. And just to verify here, we go to the file and we show that it's signed with a valid Microsoft code signing certificate. So weaponization of this technique, we have sideloading existing ClickOnce deployments, and we have identifying arbitrary .NET assemblies that we can wrap up as ClickOnce deployments. So we wrote 2 separate tools to address kind of both of those use cases. The first one is ClickOnce Hunter. It searches online. It uses some dorking techniques and will attempt to find existing ClickOnce deployments. So we'll have a demo of that here in a second. And secondly, Assembly Hunter, which Steven wrote, and he'll talk about in a little bit more detail, searches for files and other artifacts on disk that would have all of the associated attributes that we're interested in to turn something into a ClickOnce deployment that would make sense from an offensive perspective. So he'll give us some examples of that in a second. So just some dorking techniques. Here's an example of using Shodan to find some existing ClickOnce deployments. We have using some Bing specific dork techniques. And again, we basically just took the contents of what we would expect to appear in a relatively default, like the HTML or things that appear in the default ClickOnce deployments. So we can use that to find some existing ones. Something similar on GitHub here, we're looking for manifest related information associated with ClickOnce deployments. And again, here we find like this is a application manifest for a ClickOnce deployment. So here the hope would be that there's some sort of signed or reputable release associated with this project. And here's a very brief demo of what ClickOnce Hunter looks like running. So kind of out of the scope of this talk, but you'll see some AWS API gateway calls happening. And in the GitHub repo, you'll see reference to the project that we made use of, Fireprox, to leverage this technique, running a bunch of searches on Google, also using a search engine, another search engine here in a second. And it was able to gather, let's see, pause at the end of the video here. Looks like it identified about 157 existing ClickOnce deployments in just the 10 seconds or so that we let it run. So that's a brief demo of ClickOnce Hunter. And up next, we have Assembly Hunter.
Yeah, so as Nick mentioned, just like how ClickOnce Hunter goes out online and finds our first use case of ClickOnce deployments, Assembly Hunter will search a particular host for .NET assemblies. And so we can search different ways, file paths, we can look for services, tasks, auto runs, what have you. and we can get a bunch of different information, parse manifest. And so one of the things that you can do is you can just recurse an entire host looking for a specific flag. So I added a flag called ClickOnce, which will just pretty much give you every .NET assembly on an actual target host that can be turned into a ClickOnce deployment. So this is an example of finding a particular assembly that doesn't have the default settings for that can be used for a ClickOnce deployment. Here you see the default assembly identity is non-existent, so this would be usable. In our previous example, or that first one, DF Monitor, how we discovered that was initially using Assembly Hunter. So we just looked through the entire host, found a few. Chocolatey, I'm sure people are familiar with, that installs like Windows packages. Another example of something there that's signed that can be used as well, because there's no manifest associated with the assembly. An example of just recursing or looking through like the .NET framework assemblies. So if we look for anything that doesn't have a manifest an application manifest identity, and make sure that UAC settings are set. So in this first example, we have add-in process, which is usable for us. In the bottom example, we have Caspool, which is not usable because it has the default application manifest or application identity. So now that we've walked through all of our use cases, we'll talk a little bit about some detection and prevention opportunities. So going with what we stated before, ClickOnce applications are not super common. And so this is not going to be universal across every single environment. Obviously, this is going to be in accordance with a baseline. Some environments might be more common than others, but from what we've seen, it's not super common for these to be used or deployed. So baselining an environment for deployment itself, we want to look for that particular process that we mentioned before that handles all of the deployment stuff, df-svc.exe. See if there's any child processes that are spawning in from that look a little suspicious. We want to potentially whitelist any deployed or internally deployed ClickOnce applications. If this is a technology that an organization uses, then we want to make sure that only the ones that we dictate are usable are used and stop everything else from being executed. One of the things as the df-svc child process, if we do follow our process of modifying a DLL or a dependency DLL part of the ClickOnce deployment, we will be breaking that signature, and that would result in a unsigned module load. So if you have the telemetry ability to capture that, looking for ClickOnce deployments that have unsigned module loads is another pretty high fidelity thing in my eyes. dfshim.dll is another is a DLL that can deploy a ClickOnce utility as well. And this can be something that's used on the command line to launch the actual deployment itself. So more execution opportunities to look for when trying to identify ClickOnce deployment. ETW monitoring for ClickOnce deployment is another opportunity. There is some potential bypasses that exist out there. Some are public, some are not public. You can also add the ETW enable flag to the .NET config. That might be able to circumvent some of the monitoring that would be in place. So just something to be aware of. Also baseline installation directories, as we mentioned before, local app data is where these are going to be installed to by default. So check those, see if there's anything that looks suspicious. Potentially malicious code could be found in there. Uncommon applications or uncommon signatures from applications making internet connections. So if we get on the first route of taking an existing ClickOnce deployment and backdooring that and deploying that, likely it's going to be from a really uncommon or very highly unused application or signer that this came from. And so looking for these particular applications that probably will have never ran in your environment with an uncommon signature is something else to look for as well. We also have some good detection guidance on Twitter at NASBench. Also found some useful logging information for when ClickOnce is deployed. It has some example Sigma rules that can be looked at, log files, inet cache stuff that is all useful for a defender to look at ClickOnce deployments. One of the things is that there's a lot of logs that are generated whenever a ClickOnce deployment is deployed. So tons of information there that is useful for us or is useful for a defender to identify that ClickOnce deployment has happened. Some prevention opportunities. So one of the things that we can do is that we can create trust prompts that can disable ClickOnce deployments from the internet to be allowed. And so we have other options that we can set that would say from what location it is allowed or disallowed. And also just if we want to make sure that only signed applications are allowed to prevent just outright unsigned applications from running, we have the option as well. But options that we have, we can say enabled, authenticate required, or disabled. And then zones that we can define as ones that are not allowed. We can say my computer, local internet, trusted sites, internet, or untrusted sites. So if we want to disable all ClickOnce deployments from the internet, we can set this registry key. And anytime a user, if they say were to be phished and they want to run a ClickOnce application, they will not be able to. Also, if application is control, we can prevent unreputable DLLs or broken signature DLLs from being loaded as well. So an example of what that looks like. So a user goes to run the ClickOnce application. We get past that first prompt that says, would you like to open this? Open it, and there is no option for us to click run. We only have the option to click close.
Yeah, so kind of wrapping things up here, we wanted to give a shout out to a few people that were very relevant to all of this research. So the first one here is our colleague Lee Christensen. A lot of inspiration for looking into this came from work that he's done internally for our team as well as externally. So helped a lot along the way and was hugely valuable. Casey Smith as well for a lot of previous .NET research. I think hopefully here at the footer, I can't see it on my screen because the Zoom view is a little weird, but there's reference to his research associated with app domain manager injection and a lot of other useful techniques that were relevant to weaponization of this. Also wanted to give a shout out to William Burke. There was a really good Black Hat talk that's linked here at the bottom as well, with some AppRef MS specific research in regards to ClickOnce that was super useful. And kind of lastly here, the stuff that we dug into regarding ClickOnce and .NET, it still seems like to us there's a gigantic attack surface. So plenty of room for further research, things to look into regarding capability development and things of that nature. So that's it from us. We have a link to the blog post associated with this technique here at the bottom of the slide. And I know we're kind of running up on time, but we're happy to hang out for a little bit and answer any questions that folks may have. So if there are no questions, again, we'll be hanging out, but thanks to everyone who dialed in with us today. Okay, I'm seeing some questions come in. The first couple were, I see a couple regarding getting access to the recording. Helena, do you know how or when this might be available?
Yes, they'll receive it in the email that they'll get after this. They can also use their registration link after the webinar is done, and it'll take them directly to the recording.
Awesome. I see a question regarding the Shodan search. So I'll just scroll back to that if I can find it really quick. That was right here, ClickOnce info text. But the specific contents of these dorks in Shodan or Bing or Google or any of the other engines that we use, GitHub, you can use the ones that we give as examples. It would definitely be best to like make as big a list you can by looking through defaults of like default ClickOnce deployments, other people's ClickOnce deployments, and come up with some dorks for that. Let's see, recording. Okay, I have one here that says, if you use the register key to disable the thing, does that include websites as a whole, including your LAN, or is it specifically public IP addresses? That would be, Steven, when you take that.
It'd be based on the zone identification for that rather than like any sort of like IP address or domain name or anything. So there's going to be pretty much anytime a ClickOnce deployment is downloaded, there's going to be some sort of a like the system.deployment DLL handles where that came from as far as like internet, my computer and stuff like that. And so that's where that is handled.
Awesome. Can hang out for another couple seconds to make sure I'm not catching anybody like as they're about to smash enter on a question, but it looks like unless I don't know how to use Zoom, which is very much a possibility, it looks like all the questions are answered. So yeah, thanks again for everybody that dialed in, and hopefully we'll talk to you guys soon.